Section 3.2 Interactive Assignment Objective 2. We want to find the sample standard deviation for the given data that's listed below here. So we need to first look at the formula for the sample standard deviation. So the sample standard deviation is equal to the sum of the deviation squared divided by n minus 1 because we're dealing with the sample standard deviation. So the first thing we need to do is we need to calculate the sample mean, which is x bar. The sample mean is to add up all those data values, okay? So if you take a look in our first column, we listed all those data values, 20, 11, 6, 8, and 12. So we're going to add the numerators to get 57, and then we're going to divide it by the number of observations, which is 5, to give us a sample mean of 11.4. So now what we're going to do is we're going to create a new column, a second column that represents the sample mean. So what we found is that the sample mean is 11.4, so we're going to include that for each individual cell. Okay, now we have our score, we have our sample mean. Now the first thing we want to do is we want to find the deviation about the mean, which is taking the data value and subtracting the mean. Okay, so we know that the mean is 11.4, and then we're going to take the data value of 20. So 20 minus 11.4 gives us a deviation of 8.6. Okay, next we're going to take the next data value of 11. We're going to subtract the sample mean of 11.4 to get a deviation of negative 0.4. Next, we're going to take the next data value of 6. We're going to subtract the sample mean of 11.4 to get a deviation of negative 5.4. Okay, next we're going to take the data value of 8. We're going to subtract the sample mean of 11.4 to get a deviation of negative 3.4. And then lastly, we're going to take the data value of 12. We're going to subtract the sample mean of 11.4 to get a deviation of 0.6. Now when we add these all up, we should get 0 or close to 0. Now when we add this all up, we're not going to get exactly 0, but it should give us close to 0 when we add up all the deviations. But we don't really need this number, we're just showing that this is what happens. What we're more concerned about is what do we do with the deviation? We need to take the deviation and we need to square it. So we're going to take the deviation now of 8.6 and square it to get 73.96. We're going to take the next deviation of negative 0.4 and square it to give us 0.16. And then we're going to take the next deviation of negative 5.4 and square it to give us 29.16. Next, we're going to take the deviation of negative 3.4 and square it to give us 11.56. And then we're going to take the last deviation, which is 0.6, to square it, and then we're going to get 0.36. Now in our last column, what we want to do is we want to add these all up. So we're going to add everything up, 73.96, 0.16, 29.16, 11.56, and 0.36 to give us a total of 115.2. Okay, now that we have 115.2, we notice that this represents the sum of the deviation squared. So in our formula, S is going to equal, in the numerator, the sum of the deviation squared, which we found to be 115.2. We also found that the n, or the size of the sample, is 5. So we got to put 5 in for n. And then we have to subtract 1 because, again, we're dealing with the sample standard deviation formula. So now what we're going to do is we're going to take the square root of 115. So 115.2 divided by 4 gives us 28.8. And now we're going to take the square root of that number to give us 5.3665631. And this question wants us to round it to one decimal place, which is 5.4. So therefore, the sample standard deviation is going to equal 5.4. And then going back to our result, we can see that S is equal to 5.4, rounding it to the nearest tenth.